released. 10 grams was released. That area is now off limits for the next how long? Let's find out. 10 grams of plutonium. How long will it take to decay to 1 gram? What's be considered safe? Let's find out, shall we? Give me an estimate. What do you think how long it'll take to decay to 1 gram?
100 years.
200 years? Okay, let's find out.
A millennia.
Let's find out, shall we?
I was gonna
Now,
say like,
we know
so rude.
at
Look at us.
t equal to 0,
ow my ear. Oh, I forgot.
your initial condition
Like,
is 10. So C is going to equal
was your
10.
mom like aware?
So now
Did
we're
you
looking
have
for
mom?
the other one, right?
She still doesn't know.
So now we'll look for the other one.
Nice, nice.
So we know C is equal to 10, we're good to go. Then we do what's called the half-life, remember that? We find what K is. So half the time, how long will it be?
If I click off of this, what will happen?
Half-life plutonium is 24,100 years.
Okay. So it's still recording.
So to
Maybe. I
find
don't
K, we take, after 24,100 years,
Wait.
E times that value will give you half the
So
life.
we put.
So you take K is a whopping negative 0.0000028.
C equal to T10.
So based on that, if we
I don't
want
know what's happening.
it go down to 1 gram where it's safe, we multiply 10 times E is negative 0.0 times T. We don't know what T is, so we take the natural log of both sides, isolate the unknown. You get the T to be approximately 80,059 years. Who was closer? I think it was you. You were 300, right? Congratulations.
Oh, it's still recording. I said a millennia. Am I not close?
It's a 300. You were closer than 200.
I was off by like.
Only off by a little bit. 80,000 years, guys. A friend of mine who graduated and had a master's degree in math while still working on a bachelor's. She moved ahead a little faster than I did. And she became an engineer for the Department of Energy. She had to develop containers that will not only hold nuclear waste for a certain time period, but designed so that they will reduce the amount of radiation coming out. In other words, the shape of the container actually determines radiation. It's pretty cool. Use calculus all the time. Unfortunately, with a safe realm of 80,000 years, that container better be pretty dang sturdy. What they do with that container, they put it in a hole. More specifically, they put in a salt mine under the Rocky Mountains, approximately 1 mile down. They actually drilled in the salt. It's a huge salt area, and they drilled into it.
So if you just look at what happens, like, it's gonna be really salty.
And they're hoping to stay down there for another 80,000 years. In 80,000 years, there's not going to be a planet. No, probably not. Actually, I'm pretty certain it's not going to be. Earth will not
What does
exist.
that say?
We have that long to get off.
KT tape. Pardon?
You know, so peer reviewing is going, okay, time to move.
Yeah.
I think another 4,000 years our sun's supposed to expand outward, so we need to rock and roll. So you guys get to work. You have 4,000 years, find out a way to get off the planet.
Good thing I won't be
Sorry?
around. The Lord is coming.
Yes, you did. Actually,
Trust.
observation.
Period. Amen. Preach.
That's assumption, based on we were very limited on what we do know. But it's a good estimate right now, the current estimate, that the sun will expand to a red giant in roughly 6,000 years.
Yeah, and What does like, that mean though?
now?
A lot of million years,
That's how long
our days are actually going to be
recorded
25 hours
history is, right?
long.
10,000 years?
I
Yeah,
forgot
so
why,
we're
but I saw
halfway
it
through.
somewhere.
After
either
that,
about the sun or the
horizon,
moon.
you know, get off, horizon,
Maybe
or Uber's over
Let's move
after
closer to the
half
sun.
of our existence.
I don't know.
Better move.
This is a moon.
Hopefully by that time we can move the planet. Finally here. Okay, here we go. That'd be cool. Moving along. Suppose an experimental population of fruit flies increases according to the law of exponential growth. There are 100 flies after a second day of the experiment and 300 flies after the fourth day.
Right.
So again, at t, equal to 2, you've got 100. At t equal to 4, you've got 300. What are you missing? T equal what? 0. You don't have that one, right? So you can't easily find C that way, but you still have two equations, two unknowns, you're good to go. You have one equation involving 100 flies the second day, and you have another equation, 300 flies on the fourth day. So you can have two equations, one involving K, one involving, both involving K and C. Two equations, 200, you should be able to figure out the solution. The solution is as follows. First of all, here's your first two equations, see them? One involving T is equal to 2, and one T is equal to 4.
I just started it.
Got it? If we divide, what happens to my C? They go bye-bye, right? They go bye-bye. Okay? So, what's C gonna be here? They solve for C in this one, do they not, right here? They divide by e to the 2x, that would be e to the negative 2x, right? Then they replace it here, I just divide usually, it's faster that way. So, C becomes e to the negative 2x when they simply divide e to the 2x. Replace that C with this C, right? Boom, boom, boom. There's my C right there, see it? And then solve for them in K. Once they have K, plug it back into either one of the problems and solve for C. This one usually is smaller, K is better. But, you know, you have a calculator here. Okay. Questions? Again, this is not really difficult. This is actually pretty tough. Right? Not too hard. Questions? Cool. Next. Now you got a table. Now you got a table. Assuming the growth pattern of population is proportional to the population size, in other words, dy over dx is equal to k times y, that means that the equation will be exponential growth. Assuming this is true, in other words, the step from here was this one. dy over dt is equal to k times y, right? Right?
I'm gonna start doing
Right?
that.
That's what
That's what I need to
that's what it's
talk
saying. Assuming that the growth rate, proportional to population, in other words, the growth rate, the change in growth over unit time is simply a proportion of the return. That means that the solution is going to be up, 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 exponential growth. Use table 1 for the population of the 20th century, find out what the growth rate is, and then how well the data was. So let's go ahead. Initially, we're going to start at your 1900, right? That'll be time 0. What's C going to be if time 0 is 1900? 1650. That's easy. Now the K value, you plug it in, right? Which one we don't plug in? Doesn't matter. You can do the next one, you can do the one at the bottom, you don't care. Doesn't matter which one you plug in. They plugged in which one? Table what? I mean, table what?
real because I haven't done that.
Yeah, they did it in 1910. So they did the next one right here, 1750. So they're 10 years after the fact. So they did that to solve for K. They get K equals
Okay.
0.005884. Yay, positive, we're growing.
Okay.
So it's relatively 0.6% increase per year.
Oh,
If you use a different number in the table, you get a slightly different number, but it's going to be roughly the same. Got it? How accurate is it?
oh, there
We did it from 19 to 1910. So let's see how it did in 2000. It was at 6,700? 6,700? Let's see if it works. You plug it in. Well, it's not in there. I'll add that later. So you plug
Yes,
in.
and I
Well,
should
go ahead and
do
send it
this.
with the calculator.
You
1650
should go.
times e to the raise of 0.05884 times, how long is it between 1900 and 2000? 100 years, right? So see how close we are. Go. What do you get?
That's crazy.
Come off. So this assumption is wrong. Questions?
Are you freaking kidding me? Yeah, that's my question.
Half it off.
Are
In other
you
words, our
freaking
population
kidding
rate is
me?
growing. Why is our population growing? That's the problem, is rate of change
to
right
be
now.
not too cool.
Why is K increasing?
I totally forgot we were on.
Look at history between 1900 and
I forgot that the
2000. What's
paparazzi
happening?
is watching this. Oh my gosh.
Medicine's
it's
good, but
been
medicine, what
over
else?
10 minutes.
Sorry?
10 minutes of stuff.
Industrialization, what'd that do?
10 minutes of just us like going like this into the camera.
Okay, that's a life expectancy. We're talking about population growth, having babies.
Sorry, you just do that so perfect.
Mortality rate
It's like
back in 1900 was a staggering number of compared now because of better medical technology.
it's
A friend of mine, a good friend of mine, his daughter just had a baby. 6 months early. It's 9 months gestation. The kid doesn't have skin. But he's gonna live. They're going to artificially
Oh my gosh,
support him
you know,
until he
reminds
reaches
me
that
of-
point and he gets worked up. That was unheard of 20 years ago, 30 years ago. That was unheard of. That was a dream in 1900. More people are growing, more people are changing. Those are the
like hold on, dude.
Our conditions are getting better, the industrial one, you say. You have kids now. But easy. Questions? Cool, we're done. Next one. Newton's law of cooling. It's pretty cool.
Yeah.
Man.
Cool.
I think Newton would be a
Oh wait, he just said that.
I don't know if it was named after him or he actually
I
did it.
love her.
That's kind of embarrassing. You don't actually have to solve the differential equation to solve it. You actually use the differential equation itself. To solve the differential equation, you don't have to use it. Next problem demonstrates how you can use the differential equation to solve these same problems. Example is called Newton's law of cooling. And it states that the rate of change in the temperature of an object is proportional to the difference between the object's temperature and the tension surrounding the medium.
You have to write upside down and backwards.
That's a stupid rule.
Oh crap.
It says the rate of, in other words, if the warmer it is, the faster it's gonna warm up. Wow. That's man.
Nope, that's backwards.
The warmer it is, the colder your thing is, the quicker it'll warm up. Well, duh. Duh. But the key word is proportional. Proportional. So, that says that the change in temperature is directly proportional to the change in temperature is directly proportional to the actual change in the temperature between you and surrounding medium. Okay? So let Y represent the temperature in degrees Fahrenheit of an object in the room kept at a constant rate of 60. So this is your temperature of your object, that's your surrounding media. The difference between those is Y minus X. Newton's cooling says that the change in temperature, the slope, is equal to some constant, of course, that K times the difference between the two temperatures, the temperature of the object and the temperature of the surrounding area. If the object cools from 100 down to 90 in 10 minutes, how much longer will it take the temperature to decrease to 80? So we're okay with the differential equation? Y prime is equal to K times the difference in temperatures of the object minus the ambient temperature of the outside. We're good? Now we're going to say Y is between 80 and 100. That's our range, right? From 100 down to 80, right? Cool, moving on. So to solve for the differential equation, do we have to? Not really. Because when we divide by Y minus K, that's 60 of it. And integrate both sides with respect to the respective numbers Y and T on the right side respectively. Then we can solve for
Okay, so we're gonna make
so take the under root of each side,
video.
take the natural
This
log
video
of
and
Y
I should
minus
start a
60
YouTube
difference
14-minute
equal
long
to
video.
K T plus T. C being some constant. Let's plug it in. When Y is 100 at T0, that's your initial point. That's going to be your C value. C parentheses with a difference between 100 and 60, which is 40. So now we're time for K. So again, this is going to be kind of like Euler's laws. So the value of the function x plus now 40, the t times e, that's the slope. Equal to your new value. You saw it for K, right? So 3/4 equals to e to t. Take 10k, take natural log, divide by 10, each k value. Got it? It's cooling, you should take be negative. Question. You don't need the equation, you can just use the differential equation. Got it? You don't need the equation, you need the differential equation. This is the change in temperature, right? dy. From 60 to 90, 96 rather, we go from 90 down to 60. After 10, you went from 60, 100 down to 90. We started at 100, that's your C value. And then after 10, you went down to 90. So you're not using the equation per se, the differential equation, you simply use the differential equation to solve.
Man, Roy.
Got it?
Phace, man, Roy.
Questions?
When were you born? What month?
No. You have K value, plug it in, find 80.
What's halfway between?
Find
What's
T.
your birthday? April.
Y is 80, now
So
you do K
February or
values.
March?
So it's off the T.
Which one's better? February
Okay.
towards the end. Let's
So it
do
took 10 minutes to get to 90, it'll take 14 more minutes to get to 80.
year
Questions? Oh,
2000,
14.09.
1985.
Questions?
Yeah.
And you see that exponential growth again went from 100 to 90, it took 10 minutes, but to get the same distance, 90 to 80, it took a bit longer because we can find out. So it's a exponential growth becomes a decay function.
Isn't that where we were?
Questions?
No, that was a
Cool.
YouTube account.
I think that's it. So the objective for today was to introduce or to review Euler's, then go into how to solve for differential equations where they're separable, and then apply them to the decay. Any questions?
Oh.
Cool. Awesome.
Phace,
I'm
man.
thinking that the exam will ask you to
Perfect.
show it in differential equations rather
Nobody's
than
like
solve
us.
the equations.
Password. It's gonna be our name. Help. Oh, that too. That way we never forget it. Throw a number in there. 01.
Yeah, I'm wondering. I used to have a light here.
Next.
This web powers up the computer. That comes
Skip.
right here. The website right there.
Skip.
Oh, I actually went into the.
Devours.
Scroll across.
Check out our YouTube at Phace Man Roy with a PH.
It's a 75-foot. All right, go to.
Okay. Slate devoured. This is perfect.
We're doing work. We're doing review. We're done with
Okay.
the section, so.
Now we have an email
I'm
for
gonna do
our
6
YouTube
readings.
account.
All right.
What?
I think you just created.
Oh, use a Gmail. Wait.
So I think you just made a Gmail account instead of making a YouTube. Go back to YouTube.
Wait. Sign in.
There we go.
Wait, I don't think that was right. That's not right. Oh yeah, that's right. There. There's our YouTube account. Yes. Oh wait, we have to end the recording. Thanks for watching. Peace out.